Hello viewers, welcome to SciTech and thank you all for supporting this channel of designing microfluidic chips and also prototyping. And for the last video there are plenty of nice responses. Thank you all for buying me a coffee and motivating me to do more such videos. And this video is also I got it from a YouTube viewer requesting to do a microfluidic channel which is very complex. And then they have emailed me, and then in the response to that email I'm doing this video. And this video is for educational purpose only, and if you like the video, and again if you want to support me, just buy me a coffee and keep me encouraging to do more such videos. So today's video is requested by one of the intern from IT Kharagpur. So if you want to also send me videos or link the research articles, you can share to my email address. This is my email address. Share to my email address and then I'll respond as quickly as possible. So from this article, I just got the interpretations and then I'll explain you how to interpret the data from the article. So for a beginning researcher, so this reading the article itself can be difficult, and understanding the chip designing can be another hurdle. So in this video I'll explain how clearly, how easily you can understand the research article. Just keep it very simple in a simple language. So the article says that the article delivers the data on a lab-on-chip device integrated DNA extraction and solid-phase PCR array for the genotyping of high-risk HPV in clinical sample. So it is like they are doing lab-on-chip device for the PCR and the application of HPV for clinical samples, basically. So this paper is from the authors are from China. That's fine. So if we go down, so the complexity of this device I'll show you. So if you say this chip design, okay. So this chip design has, so P1 is the pneumatic, I think these are written here, yeah. So pouches are termed as P1, walls are termed as V1, and C is the reaction chamber. So by just seeing this channel, this geometry, we are not sure whether it is in 1 layer, 2 layer or 3 layer. So when I went through the article also, I found that there is little complexity involved. So if you see this here, so this is completely made using PDMS. So PDMS is like using the soft lithography process. So soft lithography, the design it has a little changes when compared to the direct 3D printing. So I'll explain the 3D printing currently, and then I'll tell you how you can do in soft lithography also. There is nothing much change. So basically in 3D printing, we'll remove the area as it is. But in soft lithography, since you need a pattern of that, so you have to, instead of removing the area, you just build the area. So if it is a hole, you build a cylinder and then pour the PDMS and get the pattern out of it. That is the only difference. And this is like 3-layered PDMS channel they have used. So instead of this, we can do a simple 3D printed one that I'll show you. So considering this line, so this line is the glass, and this is first layer, second layer, third layer. So if you see here, just by seeing this and this, it makes the normal reader a little difficult to understand in one go. So if you see this V2 is this channel. So V2 is having a third layer breakout here, and then moving it to the second layer, and then it is coming to the top. So that is represented with this gray shaded region V2. Similarly for V6. So here they have not mentioned for V6, only this layer of sectional view is mentioned, and that makes the user difficult or the reader difficult to understand how the geometry of this is. So keeping it simple, the authors want to tell that this is 3-layered channel. So that is the reason they have differentiated with different colors. So this is the first layer. The bigger circle that we are seeing is the outer dimension of this, the outer circle of this, circumference of this. And next is the second layer of this. So all these channels which you are seeing is in second layer, which is this and this, and whatever these circles are in the top layer, that is this. Okay, so basically if you see here, so there is a wall which is having a third layer connection to the second layer connection, and then the top layer connection. Okay, and even this, I think the authors have missed this V9 because they could have shaded this with this color, because it was complex for me also to understand this, and later reading everything, and then I understood that V9 is also at the third layer. So basically V2, V6 and V9, including this reaction chamber, is in third layer, and this V1, V3, V5, V4, V8, V7 and P3, P4, this all are in second layer, and the top layer is for the outlets. So I think explaining it is little complex in a limited time, but no worries, we can go through the video, the lecture that I am going to deliver now. So this is the final PDMS based device they have prepared. Okay, so let's move ahead, keeping this as a reference, and all the dimensions and everything I change because I am not going to mimic the same to same. So instead of the copyright issues, I just, since it is for educational purpose, so we do with our own dimensions. So open the new assembly file. So now in this part, let's select the top line, right? So let's keep a random dimension of the chip. Let's extrude this. So now we don't need that much, so we extrude it to 2 mm, that's it. This layer we consider for the top layer, second layer, and the underneath layer of this we will do it for third layer. Okay, so select this layer and make a sketch on this. Select this layer, make sketch on this. Okay, so now let's start with the designing of this. So first we have this circle, and then this circle, and then this circle. So there are like continuous array of circles connected with the microchannels. So randomly we have 1, 2, 3, 4, 5. So basically one P1 and P2 are at the ends, and these two are at, and then this is in the middle. So we can make V1, V2, V3 in middle. Okay. Let's make the channels. So in the same way, just draw the center line. Take a mirror copy of this. Okay, and next we have is the V1, V2 and V3. So all we can keep it as the same dimensions of 5 mm. So we can draw a center line of this. Advantage of drawing a center line is we can make it all in a one line. We'll just select this line, press Ctrl and select all these lines. Okay, make collinear. Now everything are in line. And now let's give the dimensions. So this is done. So basically we have created P1, V1, V2 and V3 and P2 that we have created. Next let's create V5, V4 and this two V6. So we can create in the same way P2 and P3 we can mirror. V1, V5, V6, V7 also we can create. So let's create that. So there is one more intersection is coming over here. Now it is fine. Yeah. So there is an extra line which we missed. So that we have trimmed it. So once we trim it, everything is okay. Okay, so these are the 1mm things. So let's have a connection to this and to this. So to do that, just select this sketch. So basically again select this sketch, this face, and once we have selected, so randomly let's take it here. So for example, I'm just planning to take it here. So better, instead of this, let's take the perimeter circle. So you can have this as one perimeter and this as another perimeter. Okay, and the So once this is done, go to features, extrude, and now this time when you're extruding, don't use this solid option, just make a thin feature and keep it to 2 mm wall thickness. Okay, and then we can make it somewhere around 3 mm in height, 3 or 2 mm, whatever is feasible, or even 5 mm. So basically this is to pour the liquid, so we can keep it as 5 mm. So this is not needed, this can be needed for the PDMS based approach, but instead you can use the walls directly. And to look it more aesthetically good, just use the fillet option which is over here. So you can just fillet the edges and that, just to look it more proper. So once you extrude, so you'll see this design is complete. Now it has the internal mic walls, so these act as the walls. So basically once we make it transparent, so you see this, and when you make the internal layer also transparent, so you can see this. So this is the complex design when a user or when a beginning researcher or beginner in research sees that it looks complicated due to this internal layers and internal structure. So I think this is the first video ever is going to publish in YouTube of designing a multi-layered channel or multi-layered designing in microfluidics. So I request all the viewers to please support me. So this is a complicated thing and I did for the educational purpose. So support me for this, just buy me a coffee and encourage me, and I'll keep doing these videos for you all. Thank you all for watching this video till the end, and don't miss till the end. What else? And if anyone is in similar need, just share me the video and the research article. And from there, I'll just go to the article and then make a video as soon as I can make. So thank you all for your patience and supporting me. Have a good day and bye bye.